we call it information statistics. This is a wide variety of things, and just statistics we do them apply to the application in quality engineering or quality control. There's several objectives we will be addressed. Explain the concept of random sampling and what the random distribution is. Why we do that? Due to the volume production, batch production, or even the resources effective or resources efficient production type. Explain the general concept of estimating the parameter. So we have mentioned while performing estimation, there's two different types. The first one, going to call the point estimate and interval estimate. Point estimation or interval estimation. And construct, interpret on the interval of a single mean and the difference of two means. So there's a population, this is what we're going to compare. The batches in quality, the different batches, different product, or different classes. This is two different populations. And construct interpreted interval on single variance. So if you, for example, this is a batch, or this is a plant, or assembly line. We like to evaluate how stable the product has been manufactured. And also compare the two variances, there's the two populations before and after the new product, or that is called the will be and A. Will be versus SE. So current we have an existing one, and there's a new one. Do we really want to adopt the new method, or we're going to purchase? We're going to perform the purchase from the new material supplier. And test hypothesis single mean, there's several single variance. Test hypothesis single proportion and p-value. So I would like to answer the approach of the p-value. 跟你讲吧，来做这个。这个把这个桌子搬过来，两个男生去把这个桌子搬过来。我没地方找。不是，就是那个讲台的那个，放东西。 P-value. What is the approach of the P-value? So P-value is a less probability we're going to support the null hypothesis, right? So the higher probability we have, the more we reject or support the null hypothesis. 懵掉了嘛？没听我讲，就在那边想什么？
有，我在看。
Okay, so how would use a p-value approach for performing the testing the hypothesis? So typically going to a higher probability of the p-value, the more we are able to not reject the null hypothesis. The much less probability we tend to reject the null hypothesis, since there's a very unlikely probability to happen in real practice. And understand how the analysis of variance are. Okay, then 4.1, statistical and sampling distribution. So why we call it sampling distribution? Since in real practice, which is not possible, we really perform the 100% inspection. 来，你们聊的书呢？书呢？拿出来，你呢？你永远讲几次啦？几次了说？对啊，你上次也没带，我只是没问而已啊。
有，上次有带。
哦 ，OK。对。So it is not possible to perform the 100% inspection. So statistical inference, here we talk about inference, is concerned with drawing conclusion we only base upon a small group of the data, a population based upon the sample data from the system. So we're going to take the sample out of the population. Why we do that? Now, however, due to the paradigm shift, we're moving toward the big data. So perspective of the elementary statistics or conventional statistics will be changed a little bit, since we can get more data in terms of the technology of the enabling sensor. So we collected abundant data, then the distribution will behave more toward or more behave like population. So inferential statistics will be much more accurate, provide much more accurate prediction than ever. So random sample is a sample that is selected so that observations are independent. We assume they are independent. Typically, which is addressed a random sample. And typically used to describe the sample size. the larger sample size, the more accurate prediction will be provided. So, random sample that is selected so that observation are independent, we mentioned before. A random sample has a property that has the same probability selection as any other sample. So that is to say, we collect the first sample of size 10. Later, 2 hours later, we select another random sample. Maybe in the afternoon, we collect the third random sample. These 3 random samples will have the same property of the probability distribution. That's why we call this a random sampling. So statistics are any function of the observation in a sample that doesn't contain any unknown parameter. So population, they're contained or defined in the population. There exists some unknown parameters. Unknown parameters. Population. For example, sigma. For example, population table, there's a mu and sigma, and there's a sample. And each can be computed x bar and x. Okay? Sure. The mu and sigma are known beforehand. No. They are unknown. So which needs estimation. Then we draw a sample on the population. So the x bar and the s are only a function of the random sample we mentioned last week. So which does not contain. Which does not contain unknown parameter. So does it contain unknown parameter? No, it doesn't. It doesn't. So what is the definition of X bar? Summation X bar minus X bar. Right? No. Yes. No. Not this one. So does it contain a mu and sigma? No, it doesn't. No. What about this? So does it contain any unknown parameter? No, neither. Neither does it. So let's say that statistic. Any function of the observation is sample that does not contain any parameters. So from here, we know that these two are estimator also statistic. Do we get it? So last one, the sample mean and sample variance, sample standard deviation are all statistics since they do not contain unknown parameters. 等一下，因为你这个没来，以前坐在这里。
用事情请假。
为什么？
不知道。
他跟谁讲？跟你讲，他怎么回事？
不知道。他说他今天要请假。
他是身体吗？还是家庭？
不知道。
不知道。你帮我问一下。
嗯。
谁跟他比较好？
我。
哦。
大家都跟他。
So observation is sample. In the sample, observation in the sample are used to draw conclusion like this. Here is our population. Everything is unknown. We like to know what's going on inside the population. That's why we need to draw the conclusion. So here is the sample average, the sample standard deviation. So difficult to draw the histogram. The histogram that is a tour. The tour typically we by visual, we call it data visualization. Data visualization. So sampling distribution, which is a statistic, statistics is a random variable, right? Statistics is a random variable. Why is true? Statistic. Called a statistic is a theta. So statistic is a function of the random sample, right? Saying x1, x2 to xn. Are they constant or random variables? Are they constant or random variables? What are x's? The boy from computer science. The x are constant or random variables? Or girl from Hong Kong. What? What is it? Random variable. So function of the random variable gotta be random variable as well. Theta is a unknown parameter. Put a caret. The caret symbol on the top to indicate is a point estimator. Then, yeah, because the different sample was will produce. No, it's a mistake because a different value, different sample with will produce a different other value statistic. So every statistic has a probability distribution, then the probability distribution of a statistic called a sampling distribution. Let me say it again. This is a statistic. This is a statistic. Since it is auto-random variable, so its sampling distribution called its probability distribution called the sampling distribution.这边打错了，应该是 will, because a different sample will produce a different other value of the statistic. 这不是 will. Then sampling from normal distribution, like this property, let me say it again. You're going to be where? Page 8. See the page 105. Page 105 on the top. So suppose that it's a normally distributed random variable with a mean and a sigma. So this is random sample size n, no problem. And distribution of this one, x bar. So what kind of distribution you will follow to? What kind of distribution you will follow to? Since we already know the x1, x2 to xn follow the normal distribution with the mean and the sigma squared. Then it is a sample average or sample mean. What is sample distribution? What kind of sample distribution will it conform to? Gentlemen? What do you think? What do you think, gentlemen? You know. What about you? Right? Hey, hello. What? You all don't know. Will any one of you know what is the distribution you will conform to? The girl from Vienna. Yeah, Mr. Yellow. Yes, overly man. Or the girl, or the twin. Hello, younger sister. Somebody? Young teen?
应该也是 normal distribution.
Yeah. They would like to take the H bar. We're gonna take exploitation, right? So the exploitation of the sum equals sum of exploitation of x1 to xn. Each random variable got to be from the same distribution. So how many mu? N mu. So n mu divided by n. So this is second moment, there's a constant will be moved out from the operator of the variance to the splitter. Equal some, since that they are independent, so there is no covariance between any pair of the x1 to xn. So covariance are equal to 0. Then, so that is equal the sum of the variance of the sum equal to the sum of the variance themselves. So how many sigma squared n sigma squared divided by n is sigma squared. So what does this formula tell us? What does it? If n is equal to 1, what is the meaning as n equal to 1, Bertie? n 等于1的时候代表什么意思？ What does it mean? Then it reduces to a single random variable. So when n equal to 1, what is the average? No, we only pick one value, the sample, random sample with sample size 1. That means this is the only observation from a random sample. Then it reduces to that, only single one, if n is equal to 1, right? Then, single. If n equal 1, I'll pick only one single random variable. If the n approaches infinity, and infinity, Yang Ting, what do you think? So we sample lots. Yeah, sample a lot. We sample 1 million. We sample 2 million. The sample size is the sample. We assume the population is infinite. 就像全世界有几十亿、40亿吧、60亿人，全世界70 yeah. The 7 billion people. Well, every time we take a sample size of the population over now maybe 2 million or something. This is really big. That. Infinity then close to 0. The variance close to 0, right? What does it mean? This will be close to asymptotic when sample size close to infinity. And this is a new, this is going to be 0. So that is a constant. With sample size, if we get a sample size so large, then our sample mean will be approaching to the real population mean. Sample size is so big, 1 million, 2 million, or even 1 billion. So the X bar will be very close to mean. The mean is the real population mean of the 7 billion people. So the X bar very close to mean as sample size is so large. Okay, then the property of sample means not restrictly exclusive to the case of sampling from the normal distribution. So, yeah, which can be written like this.